So here I'm going to give a short tutorial on how to use Sentaurus Structure Editor in standalone mode. So Sentaurus Structure Editor has the binary called SDE. And if you type SDE space help, it will give you the options. In many computers, you might need to start SDE with the option no OpenGL to avoid issues about OpenGL. So please just start it with SDE space no OpenGL. I put ampersand so that it becomes a background drop. So as I said, Structure Editor is a program for you to create a structure. It doesn't have any process simulation. If you know the final structure of your device, you want to use the Structure Editor. So how do I create something from scratch? The best, of course, if I can get an example file from someone else, that would be the best. Otherwise, I need to create from scratch. Then I will try to open the GUI on the right, and then I will use a text editor on the left. You try to choose the one that you like. In this case, I use VIM. You can use your like GMAT or other editor that you are comfortable with. So for example, I want to draw a square, a cuboid, right? So what I can do is just choose from this icon. I click on this, and then I just drag a rectangle over here. And you will see that a rectangle is created, but the most important thing is at the bottom. You see the corresponding command of this file is of this action is also created. So I'm going to copy it and then paste into my test file. And now I have the freedom to edit it. For example, as you can see, this means I'm going to create a rectangle, right, with position of this. But here I actually just randomly click the position, so the position is really not the one I want. So I can change it. For example, I can say I want to create a position as 0, x equals 0, y equals 0, and z equals 0. By using the same thing, I can say the other corner can be 1, 1, and 0. Since this is a 2D structure, so I don't need to put the z coordinate. Moreover, it also tells me what the material is. Here is silicon, I can change it, and also the name of the region. So in this case, I can call this to be a body. Right. So why do I want to do this? Because I don't want to memorize all the commands. So that's why I will try to play with this icon to create what I want. Okay. Similarly, for example, now let's say I want to create an oxide. Okay, the computer is a little bit slow. I don't know why, but let me continue. Okay, if I want to create oxide, I can just go here and just check the material that I want. Let's say oxide, right? And again, I can draw a rectangle here. And definitely this is not the position that I want, but I can just copy it. And then put here, paste, right? And I can modify it accordingly. For example, I can say, okay, maybe the top oxide is on the top of my silicon. So instead of 0, 0, 0, I mean, it also starts from 0, 0, 0, right? But it will go up. It will go to up, which is negative. So the y-axis is 1, but the x-axis may be 1e minus, let's say, 3. It means that, and it has to be negative 1e minus 3, right? So that I have a 1 nanometer thick oxide. And then I call it the gate. This is the name, right? So why this is important to copy the sentence? If I did something wrong, okay, or I close the window, I can just start from scratch. All I need to do is just copy this command, copy, and then come to here, right click, paste. And this is just because my remote desktop and network is slow now. It takes a while, but you should see something after this. Right. Now, do you see that? I do have the oxide, the silicon here. Now, so I can try to zoom in by using this icon. You can play with this. This way I click on this, and then I can zoom in. If I zoom really into it, you will see the oxide. Right? And now you can use this pen to move around, and I also can rotate. Okay? So play with this icon and you will know what it is about. Now, this is for creating the structure, but then you also need to create the doping. You use the device, create the contact, etc. Please refer to the training menu. Okay. So after, let's say I have created everything, then I can just go back to this terminal. I will save it, for example, as call it test.dvs.cmd. I save the file. Interesting. Test. Just call this dvs.cmd. This is just a command for VIM. You don't have to learn it. I just save this file and then I quit. Now, you see that I do have this file here, right? So what can I do? For example, there are many ways you can use it. Let me clean up the desktop. I go to this blanket, right? And then click on new, and then I don't want to save anything I've changed before. I can go to file and then import. And then I search for the command. And instead of .sat, I'm searching for .cmd. Always use .cmd. Okay, the file system is really slow, right? Then I find this test._.cmd. I double click and open. Do you see that it just run the file itself? And then it created the structure that I want, right? Mine is very simple, but imagine you put all the command to create the device file, then you already get the device that you want. And this is very useful so that now, for example, if you want to do any modification, all you need to do is just go back to this file and then just modify accordingly. For example, you may say, I don't want the silicon, I actually want germanium. Then you just change this to germanium, right? And then write it. So this is one way. But after you are done with your scripting, you don't want to go to GUI every time. You can run this in the background mode. SDE -E means it is in batch mode. -L means it's going to read a scripting file, which is the file you just saved, ds.dvs.cmd. Okay, and then you will just run it and finish and generate the structure. In this example, I did not generate any structure. And when this is, and you can of course just treat this as a master file and incorporate this into SWB project.